Hi everyone, this is practice formative of chapter 3, question number 18. So the following diagram shows part of the curve x equals to y times y minus 6. So from here, we're going to straight away find the y-intercept on the y-axis, because on the y-axis, x equals to 0. Therefore, we will have y equals to 0 and y equals to 6. So we have here 6 and here 0. Okay, that is from the curve. And next, the straight line, y equals to x plus 6. All right. And then we have to find the area of the shaded region. Now, you look at this area of the shaded region, it's bounded by the straight line up to here, and then the curve and the y-axis. That means if we were to find the area under the curve, the under here means towards the y-axis. So the formula to use to find the area of the shaded region is by integrating, okay, towards the y. So the subject must be x. Okay, so we have to make x the subject. So for the curve, we just need to expand it. So we have y squared minus 6y. And for the straight line, it is still y, the subject. So we have to make sure x becomes the subject now. So y minus 6. Okay. And then by looking at the area of the shaded region, so if we integrate from 0, okay, from 0 to this point of intersection, so we'll just drop down. Okay. So this part is actually from the curve. So the area of the shaded region can be obtained if we integrate the curve from 0 to this point. But the question is, what is this? So we have to find the point of the intersection. Therefore, we just let x1 equals to x2. Okay, x1 equals to x2. Therefore, y squared minus 6y equals to y minus 6. So rearrange so that we can solve quadratic equation. Okay, when we factorize, we will have y minus 1 and y minus 6 equals to 0. And therefore, y equals to 1 or 6. So 1 is here, 6 is this. It's here, which we already found. Okay, therefore, to find the area of the shaded region, we just need to integrate from 0 to 1 of the curve. So the curve is y squared minus 6y. Because we need to integrate towards the y-axis, therefore dy. So the expression must be written in terms of y. And the area of the shaded region is on the left side of the y-axis. So we will expect to get a negative of our integration. So the area, we have to put modulus so that the negative will turn to be positive. And then continue to integrate the straight line. So if we integrate the straight line, we will get the area under the curve towards the y-axis. So this is what we're going to do. Or we can use the formula of finding the area of the triangle. So in this case, y to 6 of the straight line, which is y minus 6 towards the y-axis. Okay. And now let's integrate this. So we have y cubed over 3 minus 3y squared. So we integrate from 0 to 1 with the modulus plus y squared over 2 minus 6y from 1 to 6. Okay, with the modulus. Okay, so let's substitute the boundaries in. So we have 1 over 3 minus 3, and then minus a 0. Okay, put the modulus. Okay, and from the linear graphs, we will have 36 over 2 minus 6 times 6, 36. And then we minus 1 sub in, we have half minus 6, and then put the modulus. Okay, let's put the modulus. All right, now we can use the calculator to help us to find the value here. Okay. So we have 1/3 minus 3. So we got -2 and 2/3. So after the modulus, we will have 2 and 2/3 plus, okay, so the next one, 36 divided by 2 is 18. So 18 minus 36. After that, we minus half minus 6. So half is 0.5 minus 6. We close the bracket. So we got -12.5. So after the modulus, it become positive. So 12.5. So let's add these two together. So we will have the 15 and 1/6. So 15 and 1/6 unit squared, and that will be the answer for question 18.